Oxygen, which is also known as dioxygen, it can be prepared by heating the salts of nitrite, chlorides or permanganate or dichromate. Oxygen is a non-combustible gas, but it supports the combustion. Amphoteric oxides behave like an acid as well as with a base, hence it is known as amphoteric. Ozonide oxygen means it is a mixture of oxygen as well as with the ozone. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called P block elements. Under that, we have discussed about the introduction to the group 16 elements and their electronic configurations and their occurrence and oxidation state we have discussed. In addition to that, we also discussed about the group 16 trends in their physical property and their chemical property. Today, we'll understand some of the compounds of the oxygen, that is the preparation of the dioxygen we are going to understand, which is the first elements in the group 16 and their physical property, chemical property uses and their oxides which has been formed by a oxygen we are going to understand. Already I have told that in group 16 we have oxygen, sulfur, selenium, beryllium and polonium, right? So under this only the oxygen and sulfur you are going to study in this unit. Okay. So first we will see what is oxygen and we are also going to understand the compounds of oxygen, which is nothing but a ozone, which is nothing but a isotope of the oxygen, and its preparation we are going to understand, and we are going to understand their physical and chemical property. We'll see how we can easily prepare the oxygen, that is the first thing. Okay, oxygen, which is also known as dioxygen, it can be prepared by heating the salts of nitrite, chlorides or permanganate or dichromate. First, I'll go with the nitrates of potassium, that is a potassium nitrate, which is upon heating, which gives rise to the potassium nitrate with the formation of oxygen. So just by heating the salts of nitrite or with the chloride or with the dichromate salts, we can get a dioxygen and it can be written as O2. Coming into the salts of chloride, this is a potassium chloride, oxychloride, which is upon heating, it gives rise to the KCl and also with the oxygen. KCl, which is nothing but a potassium chloride. And if I consider decomposition reactions, what is decomposition? Because of the heat, the entire product will be given to the two or more, the entire reactant which gives rise to the two or more product, right? So here, if I consider the peroxide decomposition reaction, the peroxide which is upon decomposition reaction which gives us the water and oxygen. Okay, so during this process, lot of heat will be released. Okay, the peroxide is readily decomposed to give water and dioxygen by catalysts such as finely divided metals and magnesium manganese dioxide, that is MnO2. So I can rewrite this reaction also as, so hydrogen peroxide in presence of catalyst also like manganese dioxide, it gives rise to the water molecules with the formation of dioxygen, and if you balance this equation, so this is a balanced equation. Okay, so this is how, if you consider the single reactant can also give rise to the two or more product and hence it undergo decomposition reaction. Okay, in presence of which catalyst? Finally divided any metal catalyst you can take. I have taken the manganese dioxide. Okay, this is how they will prepare the dioxygen. We have two more methods, that is by thermal decomposition. If you provide the heat also, what will happen to the decomposition process we'll see now. By thermal decomposition of oxides of the metal, low in their electrochemical series and higher oxides of some of the metal. So you can see that we have Pb3O4 which undergo thermal decomposition and to give PbO and dioxygen. Similarly, if I take, that is PbO2, if you take, it can also give rise to the PbO, that is lead oxide, with the formation of dioxygen. And coming into the silver oxide, that is Ag2O, which gives rise to the silver and dioxygen. Mercuric oxide can also undergo thermal decomposition to give mercury and dioxygen. This indicates that even though if we are taking the oxides of the metal, okay, these are the oxides of metal, it undergo thermal decomposition to give what? Dioxygen. Okay, and in the large scale, we can also prepare the dioxygen by doing the electrolysis of water. I can take water. If you do electrolysis, what does it produce? It produces oxygen and hydrogen. Okay. So this is how we can easily understand that in a large scale production, simply by doing the electrolysis, we can obtain the dioxygen. This is another way to prepare the dioxygen. So hope you all understood with the preparation of dioxygen. Next we have physical properties of this dioxygen. We know that oxygen is a colorless and it is a odorless gas. Okay, we cannot sense the smell of this oxygen, and it is heavier than air and it is slightly soluble in water, and small amount of oxygen in water is sufficient for the marine habits to survive in the water. That is why if you go to the marine habitats, you can see that lot of aquatic animals can live in a water because of very small content of water is enough for them to survive in the water. Is it right? Yes. And it has 3 stable isotopes, that is oxygen 16, oxygen 17 and oxygen 18. And we also know this dioxygen also has a paramagnetic because it contains an even number of electrons, which indicates that it do not contains any unpaired electron, hence it is paramagnetic in nature and exhibits allotropy, and one of the allotropes of the dioxygen, it is nothing but a ozone and it can be written as O3. So these are the physical properties of dioxygen. Coming into their chemical property, we know that the oxygen is necessary for the combustion, right? So without oxygen, the combustion will not take place. But in detail, if you study the oxygen, it is clear that oxygen is a non-combustible gas, but it supports the combustion. The oxygen will not involved in combustion, but it supports for the combustion, we can say. It is a non-combustible gas and it is but it can support the combustion, and it is also reactive element. It is highly reactive in nature and it directly combines with almost all the metals and non-metals. All the reactions of oxygen are oxidation reaction. So if you consider the metals as well as with the non-metals and the halogen, if it is reacting with the oxygen, all these reactions are usually oxidation reactions which is happening, and all these reactions are highly exothermic and it also reacts with many compounds under the suitable condition. This is how we can understand that dioxygen is highly reactive and it is a non-combustible and it can easily support the combustion, and also it can react with the metal, non-metal as well as with the halogen to form a oxidation reaction. Some of these reactions I have listed here. You can see that the calcium, which is a metal, which can react with the oxygen to form a calcium oxide. Similarly, aluminium can react with oxygen to form aluminium oxide. Similarly, P4 can react with oxygen to form P4 oxygen 10, and carbon is a non-metal reacting with oxygen to form a carbon dioxide. Dioxygen can also react with zinc sulfide, can form zinc oxide and sulfur dioxide. Methane, again, it can react with oxygen to form a carbon dioxide and water molecule. This indicates that our oxygen can react with metal and non-metal, and all these reactions are oxidation reaction. All these reactions are oxidation reaction. If you see that last two reaction, which indicates that even though in presence of a catalyst, the dioxygen can react with the sulfur dioxide to form a sulfur dioxide. Similarly, dioxygen can react with the HCl to release chlorine gas with the water molecule. This indicates that dioxide can undergo reaction in presence of catalyst. In presence of catalyst, it forms a different product. So, this is how we can easily understand that dioxygen can react with the metals and non-metals to form an oxidation reaction. It can also react with other elements to form a complex compound where the reaction which has been catalyzed by a particular catalyst. Coming into the uses of oxygen, we all know that oxygen is necessary for all human beings to survival. Without oxygen, we cannot live, right? So, oxygen is mixed with the helium and carbon dioxide, and it is used as a artificial respiration. And liquid oxygen, it is the most important constituents of fuels in the rockets, and liquid oxygen mixed with finely divided carbon act as a dynamite in coal mining, and dioxygen, which is also used in oxy and oxyacetylene flame used in welding. You would have seen that while doing the welding, the flame which is usually, it will be very dark in color, and also it is very hot. That is mainly because of oxy and oxyacetylene flame, and it is one of the hottest part of the flame. And it is used in manufacturing of some of the many metals, especially with the steel, and oxygen cylinders are also used in hospitals as well as in the mountain climbing, those who are climbing for the high altitude as well as in the flying purposes. So, these are the uses of dioxygen. Coming into the oxides. So, it is very important to understand that how these oxides will be formed when binary compounds of oxygen react with other elements to form a oxides. Okay, the binary oxides of oxygen with other elements are known as what? Oxides. Okay, so however, OF2 and O2F2 are not considered as oxides because even though oxygen is there, which is less electronegative as compared with the fluoride, it does not comes under the oxide formation. Okay, and many such cases are, you can see that NO2, N2O3, N2O5, and also you can see that N2O and NO. These are the oxides of the nitrogen that we have already learned, right? And the oxides can be also of two types. It may be simple as well as with the mixed one. You can see that calcium oxide, aluminium oxide, whereas in the mixed one, Fe3O4 and Pb3O4. This indicates that the oxygen can form an oxide by combining with the other elements. It may be in a simple one or in the complex one. When it comes to the classification of these oxides are of four types. First one will be acidic oxide, basic oxide, amphoteric oxide and neutral oxide. First we will see what are acidic oxides. Okay, acidic oxides are formed by oxides which combines with water to form a acidic oxide. Example is carbon dioxide, sulfur trioxide, N2O5, Cl2O7, etc. Here we have a two reaction to form acetic oxide, where oxides of the sulfur, that is sulfur dioxide, reacting with the water molecule to form a sulfurous acid. Similarly, SO3, that is sulfur trioxide, can also react with the water to form a sulfuric acid. This indicates that oxides are acidic in nature. Acidic in nature, you can see that it forms a sulfurous acid and sulfuric acids. These oxides are generally formed by non-metals, and metals with the higher oxidation state can give these oxides, for example, stannous oxide, vanadium pentoxide, chromic oxide and manganese oxides, etc. Coming into the basic oxides, these are the oxides which is formed by the oxides which combines with water to give a base. Okay, so the oxides which gives a base with water is called as a basic oxide. Example, sodium oxide, calcium oxide and barium oxide, etc. So sodium oxide combines with water to give a base, and calcium oxide react with the water to form a calcium hydroxide. Barium oxide react with the water to form a barium hydroxide. You can see that all these oxides are basic in nature. Okay, basic in nature, because even though these oxides, when it is react with the water molecule, it gives rise to the base, and these oxides are usually formed by the metals. Coming into the amphoteric oxide, the name itself shows that it is a amphoteric. Amphoteric means the oxides can behave like a acid as well as like a base. We'll see with the reaction. Okay, the oxides which we have as a acidic as well as a basic oxide is called as amphoteric oxide. Example, zinc oxide, aluminum oxide, beryllium oxide, lead oxide and chromic oxide, etc. They react with the acid as well as with the base to give a respective salts and water. So I have aluminum oxide. It can react with the base to form a sodium aluminate, which is a base, which is nothing but a salts, and you can see that water which is formed. Similarly, aluminum oxide, if it is react with the acid, okay, this is a acid and this is a base, it gives us to the aluminum chloride as well as with the water molecule. So these are nothing but a salts. This is also salt. Okay, so this indicates that the amphoteric oxides are those, if it is reacting with the acid, it forms a salts and water. Even though it reacts with the base, it can form a salts and water. This indicates that amphoteric oxides are behave like an acid as well as with a base. Hence, it is known as amphoteric. And coming into the neutral oxide, so these are the oxide are neither acidic in nature nor basic in their nature. Hence, it is known as neutral oxide. Example is water, carbon monoxide, N2O and nitric oxide, that is NO, etc. This is all the oxides of oxygen, where the classification which I have discussed. Coming into the isotope of the oxygen, that is ozone. So ozone will be represented as O3, and we know that which is a allotrope of oxygen. Okay, and it is highly reactive, hence it does not exist in a free in atmosphere near the Earth's surface. But as we move about the height around 20 kilometers from the Earth's surface, you can see that ozone layer, which is just acting like a outermost surface which is covering to the entire Earth crust, right, which is formed by the oxygen under the influence of sunlight. And this oxygen ozone layer which protects the Earth's surface from the UV radiations coming from the sun. Why the ozone is necessary? Because suppose imagine this is a Earth surface. Okay, so at the kilometer around 20, if you go around 20 kilometer height from the Earth's surface, you can see that there is a protective shield which is formed just around 20 kilometers from the Earth's surface, which is known as ozone layer. This ozone layer which protects the Earth with a direct entry of sunlight to the earth. So it protects like a covering shield to the earth, thereby it avoids the direct entry of UV radiations which is reaching to the earth. Coming into the preparations of ozone. So ozone is prepared by passing the silent electrical discharge through the dry oxygen, and it is believed that some of the oxygen molecules will be dissociate and atomic oxygen will be combined with the oxygen molecule to form a ozone. So you can see that O2, which is upon providing energy which gives to the atomic oxygen, this atomic oxygen in turn can react with a dioxygen to give a ozonide, and entire reaction can also be written as 3O2 give rise to the 2O3, and delta H, that is change in heat, that is nothing but change in enthalpy, is positive, and you can write this reaction as 3O2 give rise to the O3. It is silent electrical discharge. What is the silent electrical discharge? Silent electrical discharge, which is nothing but a sparkless electrical discharge. Okay. And the formation of the ozone, which is an endothermic process, and high temperature of electrical discharge prevent the decomposition of ozone. And you can see that the mixture of ozone and O3 which is obtained, which is contains around 5 to 10% of ozone by volume, and it is called as ozonide oxygen. What is ozonide oxygen? Ozonide oxygen means it is a mixture of oxygen as well as with the ozone, and it contains around only the 5 to 10% of ozone, hence it is known as ozonide oxygen. For this preparation of ozone, we use a special apparatus which is also known as ozonizers. Okay, the high concentration of ozone can be obtained by using the series of ozonizers, and pure ozone can be condensed by liquid oxygen later. Coming into the physical properties of this ozone, ozone is a pale blue gas with a characteristic strong smell. It has boiling point of minus 112.4 degree and a freezing point of minus 249.7 degree. It gives pale blue liquid and forms a violet black crystals, and it is heavier than air, and it is slightly soluble in water and soluble in turpentine oil and glacial acetic acid, as well as in a carbon tetrachloride, that is nothing but a CCl4. And it is when it is inhaled, okay, when we inhaled in 100 ppm level, this can cause us a nozzle destruction, thereby it causes a headache. Okay, this is how we can understand the physical properties of ozone. Coming into their chemical property, they are usually oxidizing in nature. We'll see how does it oxidizes the reaction. Okay, due to the easy with which it liberates the nascent oxygen, you can see that ozone can give us to the oxygen as well as with the nascent oxygen liberation. It is act like a powerful oxidizing agent. So if you see this reaction, you can clearly understand that it can easily liberate the nascent oxygen, right? It can easily liberate the nascent oxygen, thereby it indicates that the ozone is a strong oxidizing agent, and it oxidizes the halogen acids to give a halogen, and potassium iodide to the iodide, and lead sulfide to the lead, and iodide to the iodine. You can see that lead sulfide, which is upon reaction with the ozone to give a lead sulfate with the release of dioxygen. Similarly, iodide can react with the water in presence of ozone. It gives to the OH minus iodine as well as with the O2, that is dioxygen. This indicates that it can easily react with the halogen as well as with the some of the compounds such as lead sulfide, etc. Coming into their depletion of ozone, nowadays hope you know that depletion of the ozone, which is a major cause for the environmental pollution, right? So, if it is considered with the depletion, let's see how does the depletion will be caused first. The oxides of the nitrogen, particularly nitric oxides, are rapidly combined with the ozone. So, this causes a major depletion, okay. Nitric oxide combines with the ozone to form a nitrogen oxygen. Now, nitric oxide, which has been emitted as exhaust gas from the supersonic jet aeroplanes, and might be depleting the ozone layer in a upper atmosphere. And another threat to this ozone layer is probably possessed by the use of freons, which has been used in aerosol sprays as well as with the refrigerator. By use of refrigerator as well as in the, you can see with the aeroplanes, which has been released as a nitric oxide, which are the major cause for the ozone depletion, okay. Coming into the structure of ozone, ozone has 3 oxygen, as you know that. The 2 oxygen bond length ozone molecule is around 128 picometer, and it has a bond angle around 107 degree, and it is resonance hybrid structure of 2 main forms. You can see that this is a resonance structure of the ozone, where you can see that ozone, which consists of 3 oxygen, between the 2 oxygen we have a double bond, and alternatively another 1 oxygen atom will have a single bond. So it has a 2 resonance structure. Hope you know that how to write this resonance structure with a Lewis dot structure. Coming into the next session, in the next session we are going to understand more about the sulfur preparation, physical property and the chemical property and its uses. So, what I have done in the session, it is very important for the examination point of view. Make a note. We'll meet you with the next session. Till that, take care. Thank you.